Assalamualaikum and hi. Previously in chapter 6, we have learned about techniques of integrations. We have learned about technique of integration by part and also by substitution. So in substitution, you're going to have u and du, while in the part technique, by part technique, you're going to have u, v, du and dv. So today we're going to learn the last subtopic, which is integration of trigonometric function. So you're going to use both of the previous techniques in order for you to solve the integration of trigonometric function. So let's see what are the trigonometric function. See, knowing the derivatives of the 6 trigonometric functions, we can recognize the following integrals. So previously in differentiation, we have learned how to integrate sine and cos. So today, there are some extra function you're going to see, which is tangent, cot, and sec, cosec, and cot. So we're going to see the first one, which is sine x. Differentiate sine x with respect to dx. So you're going to obtain a cos ax. Every time you differentiate sine, you're going to have cos. So why do we have a over here? Is because you have ax over here. So you're going to multiply the a at the front. That's why we have a cos ax. And then that is for the differentiation. But how about the integration? So let's say we want to integrate cos ax dx. So in return, you're going to have the answer as sine ax plus c. See, over here, this is actually the same. It's just vice versa. Dia terbalik sahaja. Kalau kita differentiate sine, kita akan dapat cos. Bila kita integrate cos, then kita akan dapat balik sine ax plus c. C is the constant lah. Okay, then we move on to the second function, which is, let's say we want to differentiate cos ax with respect to x. Then we got negative a sine ax. Why is it we have negative over here? Is because of cos over here. So every time you differentiate cos, you will get negative a sine ax. So it will be the same for the sine. So if you have this answer, then you want to get back to the original one, or the cos x. So we integrate sine ax dx. We're going to have negative cos ax plus c. Sama juga lah. Dia just patah balik saja. Yang ni dia integrate cos, dia akan dapat sine. Yang ni pula dia sudah dapat sine, dia mau patah balik ke sini. So dia integrate the sine, then you will get negative cos ax plus c. So for this one, you don't have to multiply with the constant or the a at the front. No need. It's just for the differentiation. Then you have a at the front over here. And then extra is when we differentiate tangent ax with respect to x, you're going to get a sec square ax. So this might be something new to you, since we rarely use tangent, sec, cot, and cosec, and cot. Most of the time we use sine and cos, just for your knowledge, of to enhance your knowledge. So it's good for you to know about tangent, sec, cosec, and cot. Okay, so over here, when we differentiate tangent ax with respect to x, you're going to have a sec square ax. And then it's similar when you integrate sec square, kita dapat yang ni, kita integrate dia untuk dapatkan balik the tangent. So when you integrate sec square ax dx, you're going to have tangent ax plus c. And where does 1 over a this thing come from? Is from the ax over here. Let me conteng kejap. Okay. So dekat sini you have a, right? That's why you ada dekat depan bila you integrate, you're going to have 1 over a. Okay. But it's only useful when you have sec, not when you have cos and sine. It's not necessarily, okay, to put a at the front for sine and cos. Only for when you are dealing with sec. Okay. Next, you have differentiate of cot ax equal to negative a cosec square ax. So anything, if you are dealing with differentiation, then you're going to multiply it with the constant over here. Since you have constant a over here, so you multiply with a over here. So, but for cot, you're going to have negative. So all these things, you have to memorize. If you differentiate sine, you get cos. If you differentiate cos, you get sine. And vice versa. If you integrate cos, you're going to have sine. And if you integrate sine, you're going to have negative cos. So you have to memorize. But the most important is these two. The rest is to enhance your knowledge, okay? Untuk just for so that you know more, not only two. Okay, that one is cosec. So for when you differentiate cot, then how about when you integrate the cosec? You get this one, you want to integrate it. You integrate cosec square ax dx, then you're going to have negative 1 over a cot x. So similar, where do you get 1 over here? Is from the a over here. So kita bawa dia ke depan, dia akan jadi 1 over a. And how about negative over here? It's because of the cosec of cot. Dekat sini. And then few more functions. When we differentiate sec ax, then you're going to have a, dia bawa ke depan, dia multiply ke depan ya. This a, so dia letak ke depan, a sec ax ulang balik multiply with tangent ax. Saya rasa yang ni senang untuk ingat. Sec ax, you akan dapat a sec ax tangent x. Dia multiply with tangent x sahaja. So sama juga when you integrate this thing. You integrate this thing. Only on this part. Okay. Integrate sec ax tangent ax dx. You're going to have this thing again. Okay. And when you differentiate cosec ax, you're going to have negative a cosec ax cot ax. Or you can write it down as this way. Bila you ada ni, yang ni actually sama dengan yang bawah ni. Okay, ataupun bila you integrate, sorry. It's supposed to be this answer. I'm sorry. This one, you akan bila you integrate, you dapat this one. This is the answer. Okay. Dia dah lari sikit. And the last one, cot ax, differentiate cot ax, you will have negative a cosec square ax. Or in similar, bila you integrate cosec square ax dx, you're going to have negative 1 over a cot ax plus c. I know it's a bit boring to do trigonometric function, but just bear with me. As I mentioned previously, you only need to focus on these two, sine and cos. This is the most important. Okay? Okay. explanation. So why do we use differentiation just now? Okay, tengok tadi kita guna differentiation so that you can see it clearly. Bila you differentiate, you get the answer. You differentiate ni, you dapat the answer yang ni kan? And then tengok differentiate sin 3x plus pi over 4. Bila you differentiate sin, you akan dapat cos. And where does this 3 come from? Is from here. Dia adalah perkali for the 3. That's why it's become 3 at the front. So the rest you just tulis balik, rewrite, and change the sign into cos. That one is for differentiation. But for integration, apa yang dia nak tunjukkan di sini adalah bila you buat differentiation, you get the answer. And actually the answer here, bila you integrate this answer, you will get the original one. Itulah maksud dia. Dia timbal balik. You will get the same answer, the original answer. So what you need to know is that you should not always start with derivative to get the integration. You should make an effort to integrate directly. So apa yang saya tunjukkan di sini adalah sebelum ni kita guna differentiation dahulu. This part kalau you perasan. The whole part over here, I use the differentiation first. Then I got this answer, then only I integrate. Tapi sebenarnya, you tidak boleh terlalu bergantung dengan differentiation. You have to make an effort to integrate directly. Itu maksud dia. Inilah. Okay, let's try this. Integrate sin 2x dx. So remember, when you have sin, bila kita want to integrate sin, you want to have cos kan? Tapi dia ada negative. You integrate sin, you get cos negative. Ada negative dekat sini. Negative cos 2x. 2x ni sama juga. It remain the same, 2x. It's just that because of the integration, so you're going to have 1 over. Sebab dia adalah integration, pengkamiran. So you're going to have 1 over. 1 over 2, where does you get 2 over here? It's because of the 2x. So dia 1 over 2 lah. Let's say this one is 3x. So it's going to be 1 over 3. And then B, integration of sin x over 3 dx. See over here, dia x over 3. So bila kita integrate sin, you will get negative cos. Tapi kenapa pula ada 3 negative? Tengok kita ada cos, and then kita rewrite, tulis semula the x over 3 plus c. And where does this 3 come from? 3 ni sebenarnya dia datang daripada bila kita integrate ni kan dia akan jadi macam ni. 1 over 3. Kenapa dia 1 over 3 kan? Every time when we integrate, you have perkali dekat sini, constant for the x. So, you're going to bring it at the front sebagai pembahagi. So, you're going to have 1 over 3. Ini kan 1/3. Ini kan ada 1/3. So, bila yang ini, you tekan calculator, you akan dapat 3. Sebab itulah dia dapat 3 dekat sini. Jangan tanya pula, where do I get the negative? It's because of when you integrate sin, you're going to have the answer as negative cos. The rest, you just write it back. And then, for C, integration of sin 3x minus 2 pi dx. Okay, don't worry. I know it seems complicated since we have 2 pi. But slowly, bila kita integrate sine, you're going to have negative cos. Itu first thing you need to know. Negative cos. Then just rewrite apa yang ada dalam bracket. 3x minus 2 pi plus c. And why is it 1 over 3? It's because of the constant ataupun pekali dekat sini. Dia akan jadi 1 over. Okay, 1 over 3. Okay, next. How about this one? Sorry. Let's try sec. Integrate sec square 5x dx. So if you refer back to the first, the earliest, bila you integrate sec, you dapatlah this one kan macam ni. So, integrate sec square 5x dx, you're going to have integrate sec square, you akan dapat tangent. Sec square, you akan dapat tangent. And then the 5x, just rewrite it. Okay? And don't forget to put 1 over 5 sebab the integration. So anything perkali or the constant of the x over here, you're going to put it at the front, 1 over 5. Okay. Then this next one, integration of sec square 2x over 5 dx. Okay. So sama juga, sec square, you integrate, you akan dapat tangent. The rest yang dekat dalam bracket, you just need to rewrite. Tulis semula. And how do I get 5 over 2? 5 over 2 here is from 1 over 2 over 5. This is because this one kan? Oops. Because of this one. 2 over 5. So 1 over 2 over 5. Bila you tekan calculator, you will get 5 over 2. That's why dia dapat 5 over 2 over here. Samalah. Then C, integrate sec square pi minus x over 3 dx. So again, bila kita integrate sec square, you're going to have tangent. And dari mana dia dapat negative 3? From here, dekat sini ya. It's because over here is negative. Dia minus kan? Dekat sini dia adalah 1 over 3x kan? Jadi dia adalah yang perkali yang ini. 1 over 3. So this one, negative 3 over here, actually dia adalah 1 over negative 1 over 3. That's why you get negative 3. Itulah dia. Then this one involves sec and tangent. Integrate sec to x tangent to x dx. So bila kita integrate this whole thing, ini macam yang the earliest slide. Okay. Integration of sec to x tangent to x dx. So bila yang ini sec and tangent, when it's combined, you're going to have sec sahaja. Sec. And then 2x ni remain. And how do I get 1 over 2? It's because of the 2 over here. So it's always 1 over. 1 over of this thing. 1 over 2. And next, integration of negative 3 sec x over 3 tangent x over 3. So tengok yang dekat dalam bracket, dia repeat. Berulang. So dia akan tulis balik sec x over 3 plus c, and this one negative 9 is because of 1 over 3 times dengan negative 3 dekat depan. That's why dia dapat negative 9. Negative 3 ni yang mana? Ni ha. This one. Negative 3 yang ini. And then for C, integration of 5 sec, I'm sorry. I'm missing the C over here. The integration of 5 sec pi over 2 minus 6x tangent pi over 2 minus 6x again, 6x and dx. So again, when you have sec and tangent, when you integrate, you will always have sec, sec, and then this whole thing lah in the bracket. And how do I get negative 5 over 6? It's because of over here. How do I get 5 over 6? It's because over here you have 1 over 2. You have 1 over 2. Okay. This thing. 1 over 2 pi. So, since this one, bila you integrate, you akan dapat 1 over 2. And then you multiply. I'm sorry. I think I made a mistake over here. Let me erase first. Sorry. Okay, actually, how do I get negative 5 over 6 is because of the 6 over here and the 5 over here. Okay, kita sentiasa ambil perkali untuk x. Okay, let's see. When you integrate, you're going to have 1 over negative 6. Kan? Perkali untuk x, this one. 1 over negative 6. Multiply with 5. That's why you get 5 negative 5 over 6. Itulah dia. Okay. Oh, we have another 2 more. Oh, yes, we have another 2 tables. Okay. How about integration of cosec 3x, cot 3x dx? Again, when it involves combination of cosec and cot, you integrate this cosec and cot, and the things over here is repeated, sama, 3x. So you're going to have cosec. Cosec saja. Macam yang tadi, bila kita ada sec and tangent, kita ambil sec saja, yang di depan saja. Bila kita integrate, dapat sec saja. So, it's the same for the cosec and cot punya case. When you have cosec and cot, you just ambil yang dekat depan saja. So, you have cosec 3x, the one in the bracket or inside here will remain cosec 3x plus c. And why do I get negative 1 over 3 is because of the 3 over here. And when you integrate cosec cot, you're going to have negative. Always ada negative. That's why dekat sini ada negative, dekat sini ada negative, dekat sini ada negative. And then for B, integration of 1 over 2 cosec pi over 3 cot pi over 3 dx. So you have negative 3 over 2 cosec x over 3 plus c. Okay, why do I get negative 3 over 2? It's because this one is 1 over 3, right? This one is 1 over 3. So you have 1 over 3 times dengan yang dekat depan ni, dia ada 1 over 2. Times dengan 1 over 2. So, when you calculate, tekan calculator, you akan dapat ni. 3 over negative 2. Negative ni always ada kalau you integrate cosec cot. It's the same for this one. Integration of pi over 2. Cosec 2x minus alpha cot 2x minus alpha. And alpha is the constant. So, no need to worry about that. Just tengok what is at the front of the x. We have 2. And then you have another constant at the front over here. So that is our main constant. Okay, integrate cosec cot, you get cosec 2x minus alpha plus c. And how about this? You always have negative. And how do I get pi over 4 is from here. 1 over 2. Okay, since we already have 1 over 2 here, so we have to multiply with 1 over 2 again over here. So you have like times with 1 over 2, the perkali at the front, the constant. So that's why you have pi over 4, or because this one is pi, okay, sorry, this one is pi. That's why you have pi over 4. This is pi, and that's it for cosec and cot cases. Okay, let's see the last table. When you integrate cosec square 4x dx, since you have cosec square, so you will have, when you integrate this, you will have cot. Will have cot. Okay, negative cot. Negative, always have negative. And inside here, remain the same. 4x, akan dapat 4x juga lah. 1 over 4 because of the 4 over here. And then always have negative. And then integration of negative 3 over 2 cosec square pi of x over pi dx. Okay, negative 3 over 2 ni you can bring it at the front. Letak dekat depan siap-siap ini boleh. Letak dekat depan siap-siap. Because of it is a constant, kan? So you will have integration of cosec square, you will get negative cot. Kenapa di sini tiada negative? It's because of you have this one, kan? So dia akan jadi 1 over negative 3 over 2 times, sorry, it should be like this, sorry. My mistake. This one is because 1 over perkali untuk x. 1 over 1 over pi over here. Since you have pi. Times with, sebab ini dekat depan, times with negative 3 over 2. Sepatutnya dia ada negative sebab when you integrate cosec square, you will get negative cot. So negative akan cancel out the negative. That's why bila you tekan calculator, you will have 3 over 2 pi lah. And then for this one, integration of 2 plus cosec 3x minus 4 pi. So bila integrate constant, you will get 2x, kan? 2x minus, dia minus. Kenapa dia minus? Sebab remember when you integrate cosec square, you will have negative cot. Integration of cosec square, you will get negative cot. This is the key. That's why you have negative. Dekat sini. Dekat sini ada negatif. Jadi, cot, this one, the whole bracket is the same. 1 over 3 is because of the constant at the front of the x. Perkali dia. Okay, that's all for cosec. So I think there's lots of example. You need to try it back. And then these are some exercises. You should try it and check your answer. We have lots of exercises. And then this is another extra for you when we need to solve integration of sine to the power of n ax dx and integration of cos n ax dx. For n over here must be less than or equal to 5. Okay, since n less than or equal to 5, it can be 1, 2, 3, 4, and 5. So there are even numbers and odd numbers. Let's see for the even numbers, when n is even number, nombor genap, we can use the double angle identity of cosine. Okay, these two things in the yellow box is what we call as double angle identity ataupun double angle formula when you learn trigonometry. So these are the most important when you have to integrate sine or cos. For example, find each of these integrate sine square 3x dx. So remember, the n over here, this is the n, this is the n is even, genap. And similar with this, when you have to integrate 2 cos square 2x dx. So the n over here is also even. Okay. Then the solution. For the first one, integration of sine square 3x dx. So apa yang kita buat, we refer back to this one, the double angle formula. Since this one, dia kata, when you have sine square x, it will become 1 minus cos 2x over 2. What happened here is that here you have x, but in here you will have double of x, 2x. That's why it is given, it is known as double angle formula. Itu sebab nama dia double angle formula. Sebabnya dekat sini single x, and then over here it become double. So sama juga untuk yang ini. So, kita tukarkan yang ini dalam bentuk yang ini, dalam bentuk pecahan ni. So we have sine square 3x dx. Okay, dekat sini kita ada 3x. Bila kita tukar, we change it into this form. Integration of, we follow back this one. 1 minus cos. This one become double. 3. Ini adalah yang ini tadi. Dia double sudah. 2 kali. Double. So 3x double maksudnya 2 kali. Maksudnya you have 6x. Divide by 2 lah. Sama juga. Okay. So dari sini barulah kita boleh integrate dia. So ini kan kita boleh tulis sebagai 1 over 2. Kan dia ada pecahan, ni constant 1 over 2 kita bawa ke depan siap-siap. That's why we have 1 over 2. Yang tinggal, the remaining is 1 minus cos 6x dx. So now you can integrate. Integrate 1, you will have x. Minus, integrate cos 6x, you will get sine 6x. And remember, every time when you integrate trigonometric function, look at the coefficient. Perkali for x, 6. So you're going to divide it by 6. Dekat sini dapat 6 lah. So this is the answer. Okay, how about this one? Integration of 2 cos square 2x dx. So again, when you have this one, ini pula untuk cos. Tadi we have sine. Tadi we have sine. Sekarang we have cos. So kita refer lah balik dengan this double angle formula. Kalau what does double angle formula mention? When you have cos square x, single x, then you have 1 plus cos 2x over 2. Tengok dekat sini, this one is x. This one is 2x. Dia dah jadi double. Sama juga untuk this one. So, these 2, we can bring it outside. Boleh letak dekat depan. So, we will have 2 at the front. Integration of cos square 2x dx. So, kita letak. Tulis semula yang ini. Kita belum pecahkan lagi. Nanti yang ini, step yang ini adalah yang ini. Ini step dia. Then you have 2, tulis balik. And then you have integration, barulah kita refer yang ini dengan atas ni. So you have cos square 2x dx. Kita tukarkan dalam bentuk yang ini. This one is this one. So you have 1 plus cos 4x. Since this one is 2, so this one will become double 4x. So 2 dengan 2 ni kan boleh bawa ke depan. Actually dia samalah. Yang ni bila bawa ke depan, you akan dapat 2 times 1 over 2. So boleh cancel out. That's why dia dah sudah 2 dekat depan. Yang tinggal cuma 1 plus cos 4x dx. Then only you can integrate. So integrate 1, you have x. Integrate cos 4x, you get sin 4x over 4. Sebab ada 4 dekat sini. So, over 4 plus c. So, that is the answer. Okay. Oh, I think this one, this one is actually for this step. Dia dekat sini sebenarnya. Saya nak tunjukkan kenapa 2 tu tiba-tiba hilang. Tiba-tiba terbawa turun kat sini pula Salah. So this is the final answer. So number 2, when you have n is, that one is for the case when you have n is even number. So this is your n kan? Your n. But this one is also your n, even. So when you have n is an odd integer, so the formula that you need to use is this one. Sama macam tadi juga. Cuma dia akan tukar yang double angle formula tu, dia akan guna this one. And then dia akan use substitution method, which is a bit more complex, a bit more complicated from the previous one. So this one is not your level yet. So I only explain about the even part, okay, when n is even. So that's all for trigonometric function. You can try this. This is for n when n is even. You can try this exercise. So these are all the subtopics you need to know, all the methods you need to know in chapter 6, technique of integration. So that's all for this week.